Hi, good afternoon, ladies and gentlemen. I'm Patrick Leung from Hong Kong, the Senior Technical Services Manager of Kaixing Management Services Limited, which is the wholly owned subsidiary of the Sun Hung Kai Properties Limited. It's my great honor to be invited to share with all of you today our building operation performance and management practices at International Commerce Center of Hong Kong. Building management is a big topic which consists of a variety of aspects such as customer service and relationship management, repair and maintenance, environmental and energy, health and safety, security, cleaning, etc., etc. As we have limited time today, so my sharing will only focus on two main areas. They are building business continuity management and energy management. First of all, let me provide you some general information of our company and ICC, as well as its engineering facilities, before going through the mentioned area. Our group, Sun Hung Kai Property Limited, is one of the largest property companies in Hong Kong. Core business is the development of property for sales and investment, with complementary operations in related fields. Sun Hung Kai Properties is experienced in residential, commercial, and composite developments in both in Hong Kong and mainland China, and is committed to offering the finest properties and services. Kaixing Management Services Limited is the property and facility management arm of the group. The company is one of the largest property and facility management company in Hong Kong, managed over 130 million square feet of space with about 8,000 staff, and the first property and facility management company in Hong Kong possessing all these ISO certifications. International Commerce Center, ICC, was developed and is owned by Sun Hung Kai Properties, while the building operation is managed by Kaixing. Traditionally, main business district of Hong Kong Island is Central, while that of Kowloon Peninsula is Tsim Sha Tsui. ICC is located at Tsim Sha Tsui West, such prime location, facing Victoria Harbour, and is linked with a variety of transportation network. A lot of international investment banking and financial organizations can be found in this building. 490 meters in height, the seventh tallest building in the world, 3 million square feet in total area, the largest composite building in Hong Kong. State-of-the-art building facilities facilitate a lot in building operations and delivering excellent services to exceed our tenants' expectation. Central chiller plant consists of 6 numbers of water-cooled chillers and incorporated with 11 numbers of freshwater cooling towers. The cooling towers are the largest indoor type with about 3 numbers of floor in height. Added up with backup air-cooled chillers, total cooling capacity for the building is over 15,000 tons. Redundant design, configuration, and installation ensure high reliability of long-mode electrical power supply. In case there is problem of electricity power supply from power company, our backup generators can still supply electricity to maintain the building operations and ensure our tenants' business continuity. Incorporate with auto fuel supply system, which continuously supplies fuel for generators' use, we can further assure supplying electrical power seamlessly. Totally 86 numbers of lifts, with about half of them are double-decker, minimizing the core space demand and enhancing the traveling capacity. The lift system has destination control feature, grouping same destination users to use same lifts. This highly improves the waiting order and the lift efficiency, reduces much in the energy consumption. The lift system also has regenerative power feature, with demand of power generated due to the weight difference between the lift car and the lift counterweights during lift running compensates part of the power lead of the other lifts in the same group. ICC has a sophisticated building management system providing controls and monitoring for all E&M services in single system that is user-friendly and highly enhances the monitoring level. Providing an uninterrupted business environment and high reliability facility service to our tenants is paramount because most of our tenants operate in critical businesses. ICC successfully acquired ISO 22301 Business Continuity Management System certification in 2013, the first property in Hong Kong possessing these certifications. We plan for unexpected, formulating all necessary procedures in advance to deal with unforeseen threats and incidents. With Plan to Check as a management model, we have BCM meetings regularly to brainstorm together for raising our awareness and get ourselves well prepared. We conduct risk assessment and business impact analysis, formulate business continuity plan, and conduct emergency drill frequently. Let me show you two examples for your easy understanding. Freshwater supply is very important to us as we make use of fresh water for heat dissipation of our central chiller plant. In case of freshwater outage, we have BCP in place, making use of water tankers to deliver fresh water from other buildings nearby. In case the freshwater outage occurs at the whole district, we have designated water collection points at 2 other districts. Speed required and time consumption at every step have been precisely worked out and verified by drills. As a long-term solution, we successfully got approval granted by Water Services Department of Hong Kong Government in 2013 to install one more water supply feeder pipe, a part of the original one. Highly improves the availability and reliability of the system. Another example is how we maintain continuous electrical power supply for the building facilities and our tenants' use. Continuous electrical power supply is very important to maintain the critical business operations of our tenants. We have large amount of generators and auto fuel supply system for backup in case of the outage of a power supply from the power substation. But under a rare circumstance, the power company fails to supply electrical power and the auto fuel supply system fails to function simultaneously. We still have a backup of the backup BCP. We can gather all our staff back to ICC within 1 hour, anytime when the incident happens, and then deliver fuel from the bulk tanks and the ground level for generators used by manpower to maintain power supply to critical equipment of our tenants. Similarly, to that for water outage, this BCP was formulated with taking into account of fuel consumption rate of every generator and time need for the fuel transportation by manual. Here we go. Let's move on to the next area, our energy management of ICC. We are delighted that ICC was the first Hong Kong commercial property acquiring ISO 50001 certification in energy management system in 2011. We follow Plan to Check model to analyze our energy consumption, formulate energy management strategies, implement measures, review measures' effectiveness, and continuously improve our work in energy management. Our building management system and power monitoring system facilitate very much for our energy management. We can easily record and collect each facility's operating performance and energy consumption data for analysis. Making use of these technologies, we can also easily make operational change of the facilities to achieve more energy effectiveness. 3 levels of energy management approach are adopted for energy saving. The first level of approach is to save energy by implementing simple housekeeping practice. The second level approach is to replace the less energy efficient apparatus with the more energy efficient ones with a reasonable outlay. The third level approach is to get substantial savings over the long term with capital investment. According to our analysis, there are three major energy-consuming building facilities. They are MVAC system, electrical lighting, and lift and escalator system. MVAC system accounts for about 62% of our total annual energy consumption. Lighting system accounts for 23%. Lift and escalator system accounts for about 14%. Let me show you our energy management work in this system. Basically, our principle of operating the air conditioning system is to achieve energy efficiency include three areas. Diligently maintain the system to operate at optimal performance. Maintain the indoor temperature to achieve optimal comfort level. Control the operating hours of our system to eliminate energy wastage. We shorten the operating hours of our AHU and mechanical fans in line with our tenants' business hour without ignoring the real demand. In view that 1 degree Celsius indoor temperature higher can result in 3% electricity power saving. Indoor temperature of some common area are set between 24 to 26 degrees Celsius, achieving balance between thermal comfort and energy conservation. To achieve continuous energy saving target, we adopt life cycle commissioning and optimization approach. We have been collaborating with the Hong Kong Polytechnic University to study on air conditioning system optimization. From 2012 up to present, under collaboration between ICC building management team and the university, there is a lot of control strategies on air conditioning system optimization have been put into real operation and have fruitful results in energy efficiency. Let me take some example for elaboration. Optimize chilled water supply temperature. Raising the chilled water supply temperature can reduce chiller power consumption, but on the other hand, increase pump power consumption. As ICC is a super tall building consuming significant amount of pump energy, delivering water throughout the building, our optimal temperature not just enhances the energy performance, but also avoids valve hunting under the low load condition in winter. Optimize cooling tower control. Reducing cooling tower water supply temperature can reduce chiller power consumption, but on the other hand, cooling tower fans consume more energy. Cooling tower control optimizer collects all relevant real-time data for analysis and fits back with operation controls parameters such as the numbers of cooling towers, fan speed, and condensing water supply temperature for optimizing the system operation. With similar principle, optimizer controls the incoming flow of outdoor fresh air to reduce fresh air load without sacrificing indoor air quality in winter, and to compensate part of the cooling load in winter. Optimize chilled water pump operation for heat exchanger system. Conventionally, primary chilled water pump is for providing constant water flow through system to maintain system operation performance. According to our design, our heat exchanger system maintains high performance even under variable water flow condition, and therefore, we can simply switch off and bypass these pumps, reduce significant amount of pump energy consumption. Optimize heat exchanger control logic. Originally, operating speed of pumps distributing chilled water to heat exchangers was controlled by modulating valves. Under the modified control logic, a cascade controller is used instead. The modulating valves are always fully opened so that water loop resistance can be minimized, and in turn, pump energy consumption can be reduced. Tackling inherent deficit flow. The inherent deficit flow appeared at the chilled water bypass pipe that caused high chilled water supply temperature, reduced the operational performance, and lowered the energy efficiency of the system. This has been tackled by adopting flow limiting control strategy. By means of this control strategy, flow rate of the secondary chilled water is always limited below the flow rate of the primary chilled water. Both operation performance and energy efficiency have been improved. As for the lighting system, we adopt management by working around philosophy to explore energy-saving opportunities. We keep the over-provided non-essential lighting circuitry switched off all the time at some area, such as mechanical floors. We reschedule the lighting operating hours at all office floor and main lobbies to eliminate lighting power wastage. We delamp for some areas where original lighting provisions are excessive. Moreover, we add timers and sensors to facilitate the lighting control for the area where our BMS does not cover. We strategically phase out the original lightings by more energy efficient and LED lightings. By means of our BMS, we can preset and adjust lighting schedule with high flexibility to suit the real demands and demand changes of different locations to reduce lighting power wastage. As for the lift and escalator system, there are several energy-saving measures that low any capital investment is needed, such as replacement of lift car spot lamps with LED lamps, suspension of portions of lifts and escalators during long peak hours, night times, and public holidays. Recommend staff to use staircase for few floors travel instead of taking lifts. Planning, executing, monitoring, and review with senior management involvement. This energy management process has formed a continuous cycle and is directing ICC towards a sustainable energy improvement performance. Tenants' involvement is also crucial for the success of energy management in the building. So we keep our work transparent and close communication with our tenants. We also organize a variety of green programs for engaging them towards energy savings. From 2012 to the end of 2014, we have saved about 80% in annual energy consumption. That's quite a fruitful result that encourages us to keep doing our energy management work diligently for breakthrough. Let me wrap up this sharing session with few words. In today's business environment, world-class business require the landlords and management services office to provide quick and responsive service while maintaining an environmentally friendly and sustainable operation. Our group, our company, as well as ICC Management Services Office, work for a common goal of establishing ICC as a world-class business address that offers the highest quality in property and facility management. Thank you.